Okay, so welcome back, and today we're going to look at direct proportion, or when we talk about proportionality, we talk about how two values, two variables are related to each other. One of those ways is called direct proportionality, or being directly proportional to each other. So what is a direct proportion? It means that as one variable changes, another variable changes with it, and in the same direction. So as one variable increases, so does the other. As one variable decreases, so does the other. That's what we mean by directly proportional, or direct variation, right? They vary directly with each other, okay? So here's an example. Let's say we have lengths of wires, okay? Electrical wires. And so it's shown, it's known that the length of the wire, okay, or the amount of resistance in a wire varies directly as the length of the wire. So if the wire is longer, the resistance of the current going through that wire also increases. Okay, so if we know, for example, that a wire is 1 foot, right? So, excuse me. So a wire that's 1 foot long, we know has a resistance of 1.65 ohms. So we know R equals 1.65 ohms, which is given by that symbol, or spelled OHMS. Okay. Now, what if we have a wire of a longer length, and we know the resistance is 19.8 ohms? Same wire, same type of wire, and we don't know the length of it, and we know but we're given the resistance. R equals, what is it again? 19.8. Okay, so the question is what's the length of the other wire? Well, we could set up a relationship knowing that these are directly proportional. So that means we could set up a proportion among the two variables. Okay, so the first thing we need to recognize that this involves a direct proportion. As the length of wire increases, the resistance increases proportionally. Okay, and so in the problem, it says the electrical resistance of a wire is directly proportional to its length. The longer the wire, the greater the resistance. If 1 foot of nichrome heater element wire has a resistance of 1.65 ohms, what is the length of wire needed to provide a resistance of 19.8 ohms? Good question. So now what we're going to do is we are going to list this. Okay? Now, the fact that it's directly proportional, how do we set up the proportion? That's a good question. We got to be able to know how to set this up. Okay. What do we know about fractions? If we have A over B is equal to C over D, okay? If two variables are directly proportional, then as one increases, so does the other. Well, where would they have to be in order to have that kind of relationship? They would both have to be on the top, or they both would have to be on the bottom, because as we know with fractions, to have equivalent fractions, whatever you do to the top must be done to the bottom. So if I'm going from here to here is multiplied by 3, right? So then that means this, to go from here to this means that I'm multiplying by 3. Okay? That's the only way to give me something that goes up. Now, or if I multiply this by 1/3 to get C, that means I'm going down. And so these must be going down. Okay? But the point is they're on the same side of the fractional bar. So in order to set up a direct proportionality, the two unknowns, or the unknown that I'm trying to figure out, must be on the same, right? Same side of the fractional bar, but different fractions. So in this case, how would I set this up? Well, I'm going to put length 1 over resistance 1 equals length 2 over resistance 2. So I'm trying to find the length. So I'm going to put the lengths on the same side, right, above. And now I'm going to set it up and fill in the missing unknowns. So now I'm going to put in, this is going to be 1 foot over 1.65 ohms equals L over 19.8 ohms. And so now I solve for L. And in this case here, what do I get? I get L is equal to 19.8 over 1.65. And the answer I get is a length of 12 feet. Okay, and does that make sense? Yes. Because if I multiply both sides, this is foot in feet, this is in ohms, this is in ohms. When I multiply both sides by ohms, the ohms on top cancel with the ohms on the bottom, and I'm left with feet. So it makes sense. So the length of the longer wire, or in order to have a resistance of 19.8 ohms, I must have a length of the wire must be 12 feet. And that's it. Have a great day.